Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic frequency shift keying. So, a digital modulation technique which allows the data transmission by changing the frequency of carrier wave according to the digital modulating signal, we call it as a frequency shift keying. And this is a waveform representation for frequency shift keying. First is a digital data, second is a high frequency carrier, and third is a low frequency carrier. Fourth one is a frequency shift keying waveform. High frequency carrier will be allowed to transmit when input is 1, and low frequency carrier will be allowed to transmit when input is 0. And this is the transmitter block diagram. The FSK block diagram consists of two oscillators. One oscillator will be generating a high frequency carrier and other will be generating a low frequency carrier. The input message signal is given as an input to the modulator. There will be a switch in a case when input is 1. The high frequency oscillator 1 generator signal will be allowed to transmit. When input is 0, the oscillator 2 generator signal will be allowed to transmit. So high frequency carrier will be transmitted when the input is 1 and low frequency carrier will be transmitted when the input is 0. So with the clock, and we have input to this transmitter is a clock, and we have two oscillator signals. So two oscillator produces a high and low frequency signals are connected to a switch along with the clock. To avoid the abrupt phase discontinuities one of the output waveform during a transmission of message, a clock is applied to both the oscillator internally. So both are synchronized. The binary input sequence is applied to the transmitter so as to choose the frequencies according to the binary input. There are different methods of demodulating the FSK wave. The main two methods of FSK detection are asynchronous detector and the synchronous detector. The synchronous detector is a coherent one, while asynchronous detector is a non-coherent one. Next is a asynchronous FSK detector. So it has a asynchronous detector. It is a one in which it has a two band pass filter and will be having a envelope detector, and we have a decision circuit. So it is a non-coherent one. So here the FSK signal is passes through the two bandpass filter and tuned to the space and mark frequencies. The output from these two bandpass filter look like a ASK signal which is given to the envelope detector. The signal in each envelope detector is modulated asynchronously. The decision circuit chooses which output is more likely and selects it from the one of the envelope detector. It also reshapes a waveform to the rectangular one. Next is the synchronous FSK detector. The block diagram will be has this mixture, and we have a with the two local oscillator will be there. One input to the mixture is a FSK input, and other is a signal that is generated by the local oscillator. And we have a two bandpass filter and we have a decision circuit. The FSK input is given to two mixture with the local oscillator circuits. These two are connected to the two bandpass filters. The combination acts as a demodulator, and decision circuit chooses which output is more likely and selected from any one of the detectors. The two signals have a minimum frequency separation. And next is the advantages of a frequency shift keying. So this FSK provides a better noise immunity when compared to ASK, where ASK is easily immune to noises, easily prone to noises, easily affected by the noises, whereas immunity of noise is high in case of the FSK. And the signal transmission through FSK is very simple, and also through ASK it's also quite simple. But ASK is more simple when compared to FSK. It is suitable for long distance data transmission, and the bit error performance is better than the ASK, since FSK is less affected by noise when compared to ASK. The bit error rate in case of FSK is better than the ASK. And drawback is that it occupies more bandwidth. So whereas ASK occupies a lesser bandwidth, and also PSK is also occupies a lesser bandwidth. But whereas FSK occupies more bandwidth when compared to ASK and PSK. So it is not a bandwidth efficient one. And next is that detection of the receiver signal at the receiver side is somewhat complex when compared to ASK and PSK. So detection circuitry is somewhat complex in case of the FSK. And application is that it is used in high frequency data transmission. So whereas in case of ASK it is not suitable for high frequency data transmission, whereas FSK can be used for high frequency data transmission, and it is extensively used in low speed modems. And ASK also be used in modems, but the high speed data transmission is not, high frequency data transmission is not possible in case of the ASK. So that's all about the FSK technique. What is FSK? And we have seen what is a graphical representation of FSK, and also we have seen what is a generator block diagram and detector block diagram for FSK. In detector we have both two types. One is a coherent and other one is a non-coherent directions. And we have seen what are all the advantages of FSK and what are all the drawbacks of FSK, and also we have seen what are all the applications of the FSK, and we also seen the comparison of this FSK technique with the amplitude shift keying, and also with the phase shift keying. Thank you.